Hi everyone. Today I will be presenting our paper, Data Science Pedagogy to Support Industry, Governmental and Research Initiatives. The paper is co-authored by Dr. Kevin Dick, myself, Dr. Huda Khalil, and Professor Gabriel Weiner. And what we are presenting for Splash E today is an experience that proved to be very successful and beneficial for all stakeholders that we applied at Carleton for an upper year undergrad data science course. Start by introducing the authors, the main contributors to this experience. I'll start by myself. I'm Professor Huda Khalil, an adjunct research professor at Carleton University. I was the course designer, instructor, and developer of this course. I have substantial industry experience, and this kind of motivated me back in 2020 to come forward to the Systems and Engineering Department at Carleton with the idea of designing and offering a course for undergraduate students to teach them the fundamentals of data science. And at the same time, in that course, the full life cycle of developing a data science project would be incorporated to get the students acquainted with the different stages of developing a data science project in reality, in industry, government, or any real work environment, and developing at the same time their soft skills and technical skills that would help them be successful data scientists. I offered the course for the first time in the winter of 2021. With Dr. Kevin Dick as the teaching assistant for the first offering, who contributed substantially to the project, overseeing the projects of the students. And then in the second offering of the course in 2022, Dr. Dick was the course co-developer, designing and guiding the students throughout their developing their projects. And we also had Professor Gabriel Weiner as an advisor and collaborator through the research part of the project, through the publication and the peer-reviewed papers that we will discuss in this presentation. So the main motivation was training data scientists with a well-structured and generalized methodology to teach them the fundamentals of data science, including computational and statistical methods, and then allowing them to apply this learning to target application domains that are closer to industry practices and real-life scenarios. We also wanted to introduce the students to research experience and to the value of peer-reviewed publications, while inspiring their creativity in problem solving and in finding insights in data. The methodology that we followed was to let the lectures focus on the fundamentals of data science through the different stages of starting from formulating a question for data science, going through the data collection, and ending finally at presenting the results of data analysis. And in parallel with the lectures, we introduce a term project with assignments that are aligned with the fundamental concepts that are taught in the lectures. And at the very early stage, we explain to the students the potential of having a client of recruiting a potential client that will allow for interaction and for client interaction and getting the students introduced to industry practices. And we also introduced the students the potential of submitting their report to peer-reviewed conferences, and how this is highly beneficial for the different stakeholders in the project. In each offering of the course, the enrollment was approximately 40 to 45 students from several engineering disciplines, including software, computer systems, communications, biomedical, and electrical engineering. And the course assumed a number of prerequisites, including an undergraduate level of probability and statistics, and also a knowledge of at least one programming language. Throughout the course, Python programming language was used for developing the different like code snippets to teach used in the lectures, as well in developing the project. The course covered the span of 12 weeks with 2 lectures per week. Each lecture is 1.5 hours, covering the different aspects of data science and the different stages of developing a data science project, starting from formulating questions, data collection, data managing, data analysis, presenting the data, and throughout the lectures, different aspects of principles of data science, as well as soft skills needed, ethical values, and research concepts were emphasized. In addition to the lectures provided by the instructor, the course co-developer and project coordinator offered tutorial sessions to the students to help them throughout their project, to introduce them to useful tools, some scraping tools, for example, and an overleaf to help them develop their project report. Also, regular meetings were held for each project. For some projects, we managed to secure clients for the projects. The clients sometimes offered the data or had a problem for the students to solve by collecting the data and analyzing it. Now, for the projects with clients, there were regular meetings held with those clients, with the attendance as well of the teaching leadership. When clients were not available for the students, the teaching leadership acted as the clients for those students, where we would provide the feedback, and the students are required to incorporate this feedback in their projects after each meeting. Throughout the term, we had 3 main assignments, and this aligns with the project deliverables. The first milestone was in the beginning of week 5, and this was mainly defining the problem, what is the question to be answered, who are the team members, and the data sources when applicable. Then the second milestone was in week 8, and depending on the project, this included the data collected and sometimes the munging and cleaning of the data, the methods used to do that, and a justification for each, ethical considerations. And then the final milestone, where the project report is developed, is provided. This included the data analysis and the presentation of the findings. The course ends, the students start getting busy with their exams and the end of the term tasks that they have. And the extracurricular part of this work starts. So the teaching leadership ranks the courses, the projects, based on their quality and based on their readiness for publication. And then we start communicating with the clients, if clients are involved, and with the students who were members of those top projects. And we work with them. If the students are interested, we work with them to refine their research report and their project outcome, whether extra analysis is needed or not, or certain refinement is needed to make the project ready for conference publication. And then we start working on them towards this publication, on their report and on their presentations if their papers get accepted. Through the projects, the students got introduced to different aspects of data science and to specific domain problems. I have here a list of the projects covered in the year of 2022. That was the second offering of the course. And the topics were various. We have, for example, the first topic here, a task-agnostic knowledge graph generation, and this was on collaboration with an industry partner. The students got to learn more about natural language processing, machine learning, and producing knowledge graphs, and the team was included 5 members. The second example is a GIS transit data collection and analysis, and the students in this project got to practice transit analysis, statistical methods, geographical information systems. We also have census analysis to identify model Canadian, and again the students got to practice census statistical methods applied to a specific problem. We had other projects covering sentiment analysis, cryptocurrencies, and different statistical and data science methods. I'll give a brief idea about a couple of projects that were developed during the last offering of the course, one of which is a systematic analysis of public transit data availability in Canada. And this project was heavy on the data collection side, and through the project the students learned a lot about data analysis, spatial analysis, and geographical information systems. This is another project in collaboration with an industry partner, and it was published as well. It's a task-agnostic machine learning framework for dynamic knowledge graph generation. Through the project, the students created a generalized high-level supervised learning framework. The framework is responsible for scraping data from the internet based on parameters set by the user and generating a corpus from the results. The students also developed an interface to label the data and to perform NLP analysis on search results to create insights from this data. They applied their general framework to a case study in collaboration with the industry partner to generate a knowledge graph that describes the acquired by relationship between different companies. We applied the presented model twice, and it resulted in 15 multidisciplinary data science projects. And those projects varied and either served a client or solved a general problem in the society. The model also resulted in 18 students graduating with peer-reviewed publications, 4 peer-reviewed publications in reputable conferences. We also received very satisfying feedback from the students and the clients involved in the projects. Some students considered pursuing research for the first time during the course, and we helped those students through their project development and after the course as an extracurricular activity to finalize the research. Now, our advice to data science educators is to focus the lectures on generalized data science fundamentals, and then encourage literacy through the multiple application domains that the students will research in their projects. Lesson number 2 is to provide topics that are interesting and well formulated, preferably client-specific in some cases. And to engage the students, in our case, all projects were presented at the beginning as open problems. And we had secured with some collaboration with Statistics Canada. And Statistics Canada actually provided 3 project options, or 3 problems for the students to solve. Interestingly, only one group of students chose one of those projects, and then the 2 other projects were not chosen. And then we also provided an open problem on crypto. And again, the interesting thing that happened is that 3 students were very interested in the trendy, 3 groups of students were interested in the trendy topic of crypto. So we had 3 projects on crypto. So the lesson is that students gravitate towards data-driven projects that are most likely to be trendy or benefit them personally. Now, whether the project has potential for peer review publication or a professional benefit in the future was not really a key in the decision-making process early in the course due to the type of experience that the students have. Although this model is very successful, it is not easy to apply because the amount of work required is substantial, more than what would normally be required from a course instructor or a course developer. And thus, we think that the teaching leadership must have at least one project coordinator who would be able to support the multiple projects that span numerous applications in different domains. In our case, the course coordinator also created a GitHub repo where they listed a number of ideas for projects to the students to choose from, and they also offered a structure for the students to follow, as well as guidance throughout their projects. Lesson number 4. There is great creativity and flexibility required from the teaching leadership to keep the students interested and at the same time navigate the project scope towards a successful and a meaningful outcome that would benefit the client and the society as a whole. We dedicated a lecture for research value and research writing, and in that lecture we explained to the students how to format their report in a research in as close as possible to a manuscript format. We also emphasized the value of peer-reviewed publications, and in the different assignments we instructed the students to format their reports in a way that is closer to a research manuscript. However, the technical reports at the end of the projects represented only a premature version of what would ultimately be submitted for a conference consideration. After the course, a subset of the student groups were willing to volunteer their own time to improving their work while managing their other tasks, because the course was offered in the winter. So by the time we started working on refining the project reports, the students some of them were in co-op work, others were in summer internships. However, a subset of the students expressed interest in refining their report for peer-reviewed publications. Lesson number 6, so perhaps one of the most important lessons. The process was beneficial to students, to clients, and to teaching leadership alike. It was like a win-win for all parties involved. However, given that peer-reviewed publication is beyond the scope of a 12-week undergraduate project, this effort resides purely with the teaching leadership, and it represents a unique opportunity to promote student success and to assist them to advance their career, as well as for the involved TAs. And the result is a published peer-reviewed article, which is rare for undergraduate students, and it supports them in their future work and careers. Now, a major challenge that we faced was funding, the financial support for the students' publications. We needed funding to register students for conferences, to present their work, and to publish the papers. The problem is that regardless of client engagement and interest, securing this funding for potential publications of student-generated work is challenging. Industry partners and governmental agencies are limited in their ability and flexibility to support initiatives outside of their organizations. As such, maybe if an established collaborative agreement is in place at the beginning, that would be useful, but this is not always easy. In our case, fortunately, we have been supported by a generous departmental faculty sponsor who oversaw the publication process and helped with the funding. However, we still suggest to expand initiatives and support initiatives like ours through establishing funding pools for student-generated publications and manuscripts. Now, the last of our lessons learned brings us to the end of the presentation. Thank you very much for listening, and I'm looking forward to hearing your questions and ideas.
All right. Thanks for the team for playing the recording. And we have Hoda here to field questions. Can we check if we have questions in the room? Any questions? And online, do we have questions online? Yes, there's a question from Dennis online. The question is, how much effort was spent editing student research reports?
Well, we had different groups of students with different skills. So in some cases, the editing and the modifications were minimal, especially that we're following up with the students throughout the course and throughout the project. So at the beginning, we provided for them the format that they would provide the different milestones with, and the format that we asked for was an IEEE format, so that made it easier. So, for example, on the top of my mind, one of the students' projects required a few hours of editing because we were following up throughout. But in other cases, the editing takes much more time than expected. So it varied depending on the student group and depending on the quality of the work finished. But what helped was following up and providing guidance and templates from the beginning. I see another question there. Do you see a possibility of starting this industry data science projects also in high schools?
That's right.
Sorry?
Yes, you see the question. So what do you think?
Okay, so I think it would be hard, like introducing the idea of data science and teaching students those skills, including the skills needed in the industry in high school, is doable and it's a good idea. However, coordinating the communication with the clients and the publication would be very challenging because it already needed too much effort and time for fourth year students. So I can imagine that it would not be easy for high school students as well.
Okay. All right. Any final questions from the room? G125? Anyone? Okay. Thanks a lot, Hoda, for fielding the questions. And we are getting ready for the next presentation.